Okay, in this video we are going to discuss the work done now by the gravitational potential energy. In the previous video I discussed the work as it related to change in kinetic energy. So the gravitational potential energy can also do work on an object. And so in this video I'm going to discuss now this type of, I guess, energy transfer. And of course, we talked before that work causes a change in the energy of a system. And in the, I guess, example of the system, I'm going to use an apple here. And so work, and again, it's not a type of energy, it's a transfer of energy. And it transfers the energy between the system and the outside world. Now, energy can be transformed into other types of energy. And hopefully we'll get to the point where we're going to discuss what's called conservation of energy, where the potential energy will be depleted. And as the potential energy is being depleted, so there will be gain in kinetic energy. And as the kinetic energy now dissipates, it goes into thermal energy. So we'll talk about it a little bit later in the chapter. There are different types of potential energies. In this video, I'm going to be talking mostly about gravitational potential energy. But also there was a potential energy, as you guys remember in the previous video, when I demonstrated the Newton's second law by compressing the, actually not compressing, it was actually stretching the spring. And then the spring was able to do some work by moving the weights, if you guys remember the previous video. So in this video, I'm going to discuss now gravitational potential energy and how this energy can do work. Now, as an example, I want to use a system as some kind of an apple. Let's say I have an apple here. And let's say that I just threw this apple. This is my hand. Let's say I'm holding this apple. Again, sorry for my bad drawing, but it is what it is. So let's say I just threw the apple up a certain height, certain distance. So the apple went up. Now, the question is, a lot of times students are confused between assigning work being positive or negative. But as the apple goes up, you know that from the previous discussion that the force of gravity is the vector it's pointing downwards. And the displacement, though, the displacement here is actually in the opposite direction of the, let me just write down displacement here. Displacement is actually the opposite, in the opposite direction as force. When this happens, this is it's the best clue, in my opinion, to you should be that the work here is negative, and it's going to be mgh now. Now, so again, anytime you have a force of gravity or any kind of force acting on the object, and the displacement, it's acting against the direction of this displacement, your work will be now acting on this apple or any other object will be negative. Now, and why is it so? We can see, guys, that if we throw the apple up, first it would be given kinetic energy by my hand. But as it goes up, it slows down. What does it mean? It means that it loses energy. So in other words, it loses energy. There you go. That's your negative sign right here. Anytime an object loses energy, it's always a negative work being done. And so remember how I talked about the positive work before and the negative work? And so the rule of thumb here is that anytime the environment does work on the object, the work is positive, and anytime the system, or in this case apple, does the work on the surroundings or environment, it will be now negative work. And in this case, this apple is trying to fight this gravity, so it's doing work against the gravity, and therefore the work here is negative. Now, what happens if I now here, and this is the ground here, and I'll let this apple now just go and hit the ground. So what happens here now? So now the apple is pretty much here sitting on the ground. So now, what's interesting here now is the work positive and negative. And what's interesting here now is that the work here is, let's analyze it. So the F sub G here is, of course, in downward direction, but the displacement also, displacement here is also in the same direction. Therefore, the work here is positive, mgh. Okay? Now, again, the work here by gravity, the work that is done here by gravity is negative to the apple when you throw the apple up, and the work here by gravity when the apple just falls off my hand is positive. Here, the reason it's negative again is because you can just look at the force, direction of the force, and the direction of the displacement, and you can pretty much clearly see here that they are in the opposite direction. On the contrary, when you take a look now at the apple here, when I let it go, and what happens here is the force due to gravity is in the same direction as displacement, and therefore my work here is positive. Now think of it a little different way. Let's say I got here, I'm dropping the apple from a 2-meter distance here, and I'm trying to throw this apple now 2-meter distance. Think about this way, and if you try to hit somebody 2 meters up or 2 meters down, what do you think, which now, I guess, force generated will be greater when you're hitting somebody up same distance, or you're hitting somebody down same distance? And apparently, of course, you will realize that when you throwing with the same kinetic energy the apple up or apple down, you will, of course, will do much more work when the apple goes downwards. And so in the next video, we're going to do some problem solving.